Good morning, students. Welcome to Haslan. This is the second session for the day. That is geometry question discussion, in which we'll be taking up some important questions from geometry to give you a review of some of the important formulas and concepts, and to make you understand the difficulty of questions in the exam. We'll be taking questions from various difficulty levels, from the basic to the advanced, all in this one session. All right. So to start with the question, there'll be a question on the screen. If you have a pen and paper with you, and if you're familiar with the formulas and concepts of geometry, that you can start solving the questions and posting the answer in the comment section. If you're not familiar, then you can use this class as a class where you get to understand some of the important formulas and get familiar with the questions from this topic of geometry. Okay, so let's start with the first question for a day. In triangle ABC, so this is a triangle here. In triangle ABC, AB is equal to 10, BC is equal to 12. If AC is a positive integer, then how many values can it take? In triangular ABC, if AB equal to 10 and BC is equal to 12, if AC is a positive integer, then how many values can AC take? And the answer options are A 20, B 21, C 19 and D 18. So what is the answer for this question? Look at the question, and if you know the basic concepts of triangles, then you will be able to solve this question. So solve the question and post the answer in the comment section. Let me see how many of you know the answer for this question. In a triangle ABC, so there's a triangle given to you, ABC. What type of triangle it is, we don't know. So we'll just make a rough diagram here. Okay. The triangle ABC, AB equal to 10 and BC equal to 12. AC, we don't know what AC is, but we know AC is a positive integer. How many values can AC take? So this question is based on two of the very fundamental concepts of geometry. That sum of two sides in a triangle, sum of two sides is always greater than the third side. That is concept number one. And difference of two sides is always less than the third side. So these are two elementary concepts of geometry. You can note down. If you are not familiar, you can note down. And then using these two elementary concepts, we can solve this question. So the third side AC will be less than the sum of the other two sides. So 10 plus 12. AC is less than 22. And AC will be greater than the difference of the other two sides, 12 and 10. So AC is greater than 2. So AC can take any value starting from 3 and up to 21. That means AC can take 19 possible values. If you count from 3 to 21, there are 19 values, and that is why the answer for question number 1 is C. And this is an important concept of geometry, an elementary concept, that the sum of two sides of a triangle will always be greater than the third side, and that the difference of two sides will be less than the third side. Okay, done. The first question and the first concept that we have discussed with the question number 1 here is done. Let's move on to question number 2. All right, another question from triangle. The sides of a triangle are 9 centimeter, 12 centimeter and 15 centimeter. What is the area of the circle that is inscribed inside the triangle? The sides are 9, 12 and 15, and inside this triangle a circle is inscribed. What is the area of the circle? Okay, so we know that this triangle has sides 9, 12 and 15. From this, can we understand that this is a right angle triangle? A right angle triangle is one in which the square of the smaller sides is equal to the sum of the squares of the smaller sides is equal to the square of the larger side, the hypotenuse. And you can see here 9 square is 81 and 12 square is 144. Is it equal to 225? Let's just add and check here. Yes. So this is a right angled triangle. Okay. Now here, if you make this triangle and first let's make a circle first. Just to inscribe the circle in a right angle triangle. Let me draw a right angle triangle here. And inside this triangle there is a circle inscribed. Okay. So let me just 1 second. So we have this triangle and let's say this is 9 and this is 12 and this is 15 and this is a right angle triangle. So what is the area of the circle? Now you should know that the formula of area of a triangle is also equal to R into S. If you don't know, you can note down this formula. And in the formula of area of triangle R into S, R is the radius of the in circle, radius of the in circle. In circle means circle inscribed inside the triangle. Okay, what is R? R is the radius of the in circle. And what is S here? S is a semi perimeter. Semi perimeter means half of the perimeter. So let's first see, do we know the semi perimeter in this question? The semi perimeter is 9 plus 12 plus 15. That's equal to how much? 36. And divide by 2, the semi perimeter is 18. So we know the semi perimeter. If you can find out the area of the triangle by using half into base into height, half into base into height, that gives you 54. So area of the triangle is 54 and semi perimeter is 18. So we can put it in the formula here. 54 is equal to R into 18, or you can cancel 18 3 times 54, R equal to 3. So what do we get to know? That the radius of the circle is 3. And once you know the radius of the circle, we can find out its area, because we know area of circle. Circle area is equal to pi r square. Pi r square. So pi into 9, 9 pi square centimeter. That's your answer. Answer option B. The area of the circle that is inscribed inside the right angle triangle having sides 9, 12 and 15 is 9 square centimeter. That's the answer for question number 2. And we have covered two things here. In fact, three things you can say. First, we have understood what is a right angle triangle. The Pythagoras theorem used in this question, the sum of the squares of the smaller sides is equal to the square of the largest side. And once you know that it is a right angle triangle, we can make the triangle and there's a circle inscribed inside the triangle. Then we have to use this very important formula without which this question cannot be solved. And that formula is that area is equal to R into S, where R is the in radius, the radius of the circle inscribed inside the triangle, and S is the semi perimeter, half of the perimeter. Okay, so I hope you have noted down the solution of this question number 2. Let's move on to question number 3 and look at the questions that we have in question number 3. Okay, question number 3 here. What is the area of a rectangle having diagonal equal to 13 and breadth equal to 5? So what is a rectangle? A rectangle is a figure where all angles are 90 degrees, so that's what we know is a rectangle. And we also know that in a rectangle, opposite sides are parallel and equal. So if this side is L, the length, this side is also L, it's the length, and this side is B, which is the breadth of the rectangle, the width of the rectangle, then this side is also B. This is what we know about rectangles, that opposite sides are equal and parallel and all angles are equal to 90 degrees. Two basic formulas of rectangles are, so I'm discussing some of the theory part of rectangles here with you. That perimeter P is equal to 2 times L plus B. 2 into the sum of length plus breadth. So L plus L is 2L and B plus B is 2B. So 2L plus 2B is equal to 2 times L plus B. The area of a rectangle is equal to length into breadth. And if you see this diagonal of the rectangle is equal to under root L square plus B square. Now that's again using the Pythagoras theorem that the length and breadth and the diagonal form a right angle triangle. So using Pythagoras theorem, the diagonal is equal to under root L square plus B square. Now in the question given to us here is told that this diagonal is 13. So what is diagonal equal to? 13. And the breadth is equal to 5. What is the length, what is the area of the rectangle? So length is equal to under root 13 square minus 5 square, and that is equal to under root 169 minus 25 under root 144, which is equal to 12. So length is equal to 12. Once we know the length of the rectangle, we can find the area, length into breadth, 12 into 5, which is equal to 60. So area of the rectangle is 60. That's your answer, option B. Now one technique that I want to discuss with you here, which can make solving these kind of questions a matter of just like 5-10 seconds, is what is called as Pythagorean triplets. Okay, so I'll just show you here what is the concept of Pythagorean triplets. You note down Pythagorean triplets. Now these are a set of 3 numbers which make a right angle triangle, and some of the most common ones, almost 80 to 90% of the questions in exams from right angle triangle are based on these triplets. So you can see here 3, 4, 5. So 3 square plus 4 square is equal to 5 square. 3, 4, 5 make a right angle triangle. 5, 12, 13 make a right angle triangle. You can note down these triplets and remember them. 5, 12 and 13 make a right angle triangle. 8, 15, 17 is the third very common triplet you see in exams. Then we have 9, sorry, let's write on 7, 24, 25, and then finally 9, 40, 41. So these 5 triplets, if you can learn, will help you solve questions very quickly in the examination. The advantage of knowing these triplets is the moment I see that one side is 5 and one is 12, in a right angle triangle, I automatically know the third side is 13. So I don't have to do all the calculation that I've done here. So if I see one is 13 and one is 5, then the third side, unknown side, is 12, and 12 into 5 is 60. I can mark the answer directly as 60 centimeters square. Not just that these right angle triangle triplets are there, but their multiples also make right angle triangle. For example, if I take the number 3, 4 and 5 and then I multiply it with any number, the resulting numbers will also make a right angle triangle. So 9, 12, 15. If you can see question number 2, the triplet was 9, 12 and 15. That was derived from the basic triplet 3, 4 and 5. So knowing these 5 triplets will help you solve questions very quickly in examination. So that's question number 3 for you, and an additional concept of right angle triangle triplets, Pythagorean triplets. Let's move on to question number 4 now and see what do we have for question number 4 here. What will be the cost of paving a footpath having a uniform width of 1 meter around a rectangular garden having perimeter of 324 meters at the rate of 20 per square meter? Look at the question again. What will be the cost of paving a footpath? So you have to find out the cost of paving a footpath having uniform width of 1 meter around a rectangular garden which has a perimeter of 324 and the rate of rupees 20 per square meter. So total cost is always equal to area into cost per unit. Cost per unit. Now cost per unit is already given to us in the question, that is 20 per square meter. So I just have to find out the area of the rectangular area of the footpath around the rectangular garden. So let's first draw the diagram to make you understand how this all question is set up. So we have a rectangular garden, and around this garden, so this is a rectangular garden, rough just drawing. So let's say the length is L, this is the length and this is the breadth B. We don't know what is L, what is B. And around this garden there is a footpath of uniform width 1 meter. So not drawn to scale. This is a footpath around the garden having a uniform width of 1 meter. The width is 1 meter every side. This is also 1 meter. This is 1 meter. So the width is uniform 1 meter. This side also we have 1 meter. And this side also we have 1 meter. So this is the uniform width, or the footpath of uniform width. So now the length is L. So the outer length, this entire thing, will be equal to how much? So we have 1 meter on the left hand side, 1 meter on the right hand side. So the outer one will be L plus 2. The outer length is L plus 2. And if you look at the breadth here, this outer breadth is equal to B plus 2. Now why B plus 2? Because we have 1 meter on the top and we have 1 meter below here, right? So we have 1 meter above and below. So 1 plus 1, 2. So the outer length is, outer breadth is B plus 2 and the outer length is L plus 2. We have to find out the area of the footpath. So that is equal to outer area minus inner area. This is a very common template of question that you will see in the exams. You have to find out what is the outer area minus inner area. So area of footpath is equal to L plus 2 length of the outer rectangle into B plus 2 the breadth of the outer rectangle minus L into B the length and breadth of the inner rectangle. So let's open the brackets here. So we'll get L into B, LB plus 2L plus 2B plus 4 and then minus LB. So minus LB plus LB gets cancelled and we get here 2 times L plus B plus 4. 2 times L plus B plus 4 is the area of the footpath, and out of this we know what is 2 times L plus B. Perimeter is equal to 2 times L plus B. This is the formula for perimeter I gave you in the previous question, and we know the perimeter is given to us in the question here. Question number 4 gives you the perimeter is 324. So area of footpath, just writing here area F, area of footpath, 324 plus 4, that is equal to 328. And we know that the cost is 20. So total cost is equal to 328 into 20, which will be equal to 9560. And that we don't see in the answer option. So the correct answer will be E. We see a 3280, but the cost of paving the footpath is 20 per square meter. Whereas, so we have to multiply area of the footpath 328 into 20, which is 9560. The correct answer will be answer option E, none of these. So this is a very common template of a rectangular based question from volume and surface area from geometry. Let's move to question number 5 now and see what is there in question number 5. The capacity of a right circular cone is 462. Capacity means volume. Capacity is volume. We're talking about a right circular cone. So what is a right circular cone? This is how we have a right circular cone. A conical shape, the circular cross section. This is what is called a right circular because it is circular in shape, and it's a cone. It's a conical shape. So right circular cone. So if you make the height of the cone, this is the height. If you drop the height and you look at the base, the radius r and the height h, the height is perpendicular to the radius, and the cone also has what is called as a slant height. L is equal to slant height. In case you don't know, you can write down the slant height, the inclined height of the cone, slant height. We don't need slant height in this question. This question is based on volume, and the formula for volume of a cone is 1 by 3 pi r square h. This is the formula for volume of cone, and it's given to us as 462. So I'll just write on it as 462, and let's put the values here. 1 by 3 pi, then take it as 22 by 7 r square. We don't know what is r, so let it be r square, and h is 9, so that's 462. Okay, and fine. So let's cancel this. 3 will cancel 9 3 times, and 3 will cancel this 154 times. 22 will cancel this 7 times, and so we get r square equal to 49, or r equal to 7. So the radius is 7. You have to find out the diameter of the base. If radius is 7, the diameter will be equal to 14. So 7 plus 7, 14. The diameter we know is 2 times radius. 2 times the radius, right? So 2 into r, 14. So the correct answer is A, and this gives you a quick revision of the right circular cone in geometry. Question number 5 we have done. Let's move to question number 6 and see what is there in question number 6 here. Okay, a very important question of geometry. If the length of a rectangle is increased by 10%, so we don't know what is the length. So it's a rectangle given to us, and for this rectangle, the length is increased by 10%. So the length is increased by 10%, and the breadth, the width of the rectangle is reduced by 10%. Okay, so the breadth is reduced by 10%. What will be the effect on its area? What is the percentage change in area of the rectangle? Is it A, 1% increase, B, 0% increase? Length is increased by 10% and breadth is reduced by 10%. So will they cancel out each other? And will the effect on area be 0%? Will the area increase or will it decrease? So we have to find that out and mark the answer. And we are going to use a very important shortcut formula here. And that formula is the formula for successive percentage change. So this is actually a formula for from the topic of percentage, but it is applied in a number of questions of geometry like this. Successive percentage change formula. So this formula says that if something is increased or decreased by A%, and then again something is increased or decreased by B%, then overall percentage change can be given as A plus B plus A into B by 100%. So we can just use this, Also keep in mind in these kind of questions, when we have increase, we take the sign is plus, and when we have decrease, we take the sign is minus. So in this case, first we have 10% increase, and then we have the breadth decreasing by 10%. The overall change will be 10 minus 100 by 100, because 10 into 10 is 100, and percentage here. So minus 1%. Now minus here signifies decrease. That means the correct answer is answer option D, that the area will decrease by 1%. That is question number 6. The length is increased by 10% and the breadth is reduced by 10%. Net effect on the area is that the area will decrease by 1%, and we are using this direct shortcut formula of A plus B plus A into B by 100% for solving this question number 6. And this question of successive percentage change has application in wide number of questions, various types of questions from different topics of mathematics. Let's move on to question number 7 and see what do we have for you in question number 7. The ratio between the length and the breadth of a rectangular plot is 7:5. So we don't know what is the length. The ratio of length and breadth is 7:5. If the perimeter of the plot is equal to 144. What is it? Now we know the formula for perimeter is 2 times L plus B. So L plus B is equal to 72. What is its area? Now that we know that ratio is 7:5, so we can say 7 and 5, let's say L plus B. So 7 plus 5 is 12, but we know the actual value is 72. So how much I should multiply? I'm doing this by the common factor of multiplication. 12 into 6, 72. So 5 into 6, 30. The breadth is 30, and 7, 6, 42. So the length is 42. So the area will be equal to 42 into 30. Let's just work it out. It's 1260 square meters. So the correct answer, very simple question, the correct answer is answer option B, 1260 square meters. Question number 7, answer option B, basic application of formula of perimeter of a rectangle, area of a rectangle, and the basic concepts of ratios applied in this one question. So now we'll move on to the next question for the day. That's question number 8. We'll see what is there in question number 8 for you. Now this is a question from a previous examination from CAT, that is Common Admission Test for the IIM. So we're going to do the MBA from IIM. So we'll see some of these advanced questions and see how these questions can be solved, what is the best way to interpret these questions, and also these questions can come in other exams also, like MAT or CLAT or any other examination where geometry is a part of the aptitude test. In most of the aptitude tests, geometry can come, and if you know how to solve these questions of higher difficulty, as such, you will have a better understanding of geometry. So let's look at question number 8. In the figure given below, ABCD is a rectangle. The area of the isosceles right triangle ABE. Now they're saying that this right angle triangle, obviously this is a right angle triangle, is isosceles, which means AB is equal to B, but it does not look like that when you look at the image on the screen. So don't worry about that. Most of the diagrams given to you in exams are not drawn to scale. We don't need to worry about that at all, right? What is given to us is that the area of this triangle is 7. So I'll just write on here 7. All right. And also it's given to us EC is equal to 3 times BE. So the ratio of BE and EC is 1:3, because EC is 3 times B. So if B is 1, EC will be 3. What is the area of ABCD in centimeter square? I will solve this question in a very simple way, very easy way, and that's how we have to solve the questions in exams. Not that we have to do it a very lengthy way and complicated. Use your logic. Let's first make this into a square. Let's say this is the point which we call as E dash. Okay, so this is the E dash. So this A, B, E and E dash is a rectangle in itself because we have made a perpendicular line there. And we should know that in a rectangle, when we make the diagonal, so it's not looking like a rectangle, just understand, stop drawing. In a rectangle, when you make a diagonal, then the rectangle area gets divided into half and half, so x and x. So if the lower triangle has area 7, then the upper triangle also has area 7, and so that therefore the area of the rectangle ABE dash ABE dash is 14. This total area is 14. Second thing to understand about rectangles that will make it this question very easy for you is that when we have a rectangle and we draw a line that cuts the rectangle in the ratio x is to y. The base is in the ratio x is to y. The length is in the ratio x is to y. The breadth is same. So the breadth is same and the ratio of length is x is to y, then ratio of area is also x is to y. Okay. So if B is to EC is 1 is to 3, then the area of ABE dash, area of ABE dash and area of E dash E CD. So this entire rectangle, okay, this entire rectangle and this rectangle here will have ratio of area is 1 is to 3. So if this is 14, as you can see from the diagram, we are multiplying 14 times. This also should be multiplied 14 times 42. And the area of ABCD, the total rectangle, is equal to sum of these two areas. This area here, 14, and this area 42. So adding the two areas, we can get 14 plus 42, which is equal to 56. So that is the answer for question number 8, D. So we have not done any complex calculation, mostly by logic. So first we see that the diagonal is cutting this into half. So this is 7, this part is 7, and the remaining part will also be 7. 7 plus 7, 14. Multiply 14 into 3, 42, you get the remaining area. And adding 14 plus 42, you get 56. That is the final answer for question number 8. And now we'll go to question number 9. Again, this is from the common admission test, that is CAT. A question from a very interesting question from geometry. So we have a circle with radius 2. Look at the question, what is it telling you? So we have a circle with radius 2 is placed against a right angle. These two lines you can see here. Okay, let me draw. This line and this line are at right angles. So this is right angle. Okay, this is a very small space here that's not visible. If I draw it, just enlarge it. So this smaller circle that you see, the smaller circle, the small space here, this part. Okay, that is, the circle is not touching the corner. This is right angle. Okay, and then we have a bigger circle outside. Okay, this is the bigger circle. So this is the bigger circle, and this is a smaller circle, and the way it is drawn, let me just try to draw it a little bit more neatly for you. Okay. And it is touching this side, and it's touching this side also. 1 second. I extend this, touching this side also. Okay. This is a large triangle. So there's a little gap here. What is just important to understand is that there's a little gap here between this larger circle. So this is the center of the larger. So this is the center of the larger circle, and this is the center of the smaller circle. And then we connect the center of the smaller circle and larger circle, straight line like this. Okay, and we have to find out what is the radius of the smaller circle. Fine, so let's just work it out. Okay. So we know the radius of the larger circle. If we drop a perpendicular here, this radius is 2, and so if I drop a perpendicular this side also, this is also 2, this will also be 2, and this is also 2. This entire line from here to here is equal to the diagonal of a square having sides 2, 2, 2, 2. So this entire line will be equal to 2 root 2. Because for a square having sides a, let's quickly draw it here. For a square having side a, the diagonal is always equal to a root 2. Okay, that's first thing to understand. Now we know that from this point to this point here, this dot is radius, so this is 2. And similarly, if I understand, just let me take another color just to show you. If I take this smaller circle and say this smaller circle has radius r, and this part from here to here will be equal to r root 2. This part will be equal to r root 2. So we can finally say that this 2 from here to here is 2 plus, one second, 2 plus this r root 2 is equal to the total length of the diagonal, that is 2 root 2. So r root 2 is equal to 2 root 2 minus 2, and r is equal to 2 minus 2 by root 2. So if you multiply root 2 above and below, you multiply root 2 and root 2, so we get 2 minus 2 root 2 by 2, or r equal to 2 minus root 2. Okay, so just let's see this once again. The circle radius 2 is placed against a right angle, and the small circle is also placed as shown in the drawing. What is this smaller circle? Correct. So the outer part, this is 2, and this is also 2. So there's a square, and that square, the diagonal is equal to 2 root 2. And if you look at from this point to this point, this is equal to 2, and the remaining okay, so we have an r missing out here. That's what. Let's just make a little correction here and solve this entire question. So small correction is required. One part we had missed out, so we'll just bring that part, and that will give you the final answer. Okay, so what was that one part which we had missed out? Let's see. This 2 we have taken, correct? So 2 plus this r also we need to take from this point to this point, that is r, and from this point to this point, that is r root 2, is equal to the total, that is 2 root 2. So r plus r root 2 equal to 2 root 2 minus 2, and r is common, so 1 plus root 2 is equal to 2 root 2 minus 2. So r equal to 2 root 2 minus 2 by root 2 plus 1. And so you multiply here root 2 minus 1 and divide by root 2 minus 1. Then you can simplify. Let's do the simplification to get the answer. Okay. So when you simplify, what do we get here? 2 root 2 minus 1 into root 2 minus 1 divided by using a plus b into a minus b equal to a square minus b square. We get 1 in the denominator, so that's ruled out. And then we multiply 2 root 2 into root 2, that is equal to 4. 2 root 2 minus 1, which is equal to minus 2 root 2 minus root 2 plus 1, that is equal to minus into minus is plus. So again, so let's see once again, 2 root 2 into root 2, that is equal to 4, and minus 2 root 2, 2 root 2 minus 1 minus 2 root 2 minus root 2 plus 1, so that's equal to 5 minus 3 root 2. Something miss here, just let's see once again. 2 root 2 minus 2 we have taken, 2 root 2 minus 2 is there. Okay, just one correction again. Alright, we got the answer here. So 4 minus 2 root 2 minus 2 root 2 plus 2, 6 minus 4 root 2, and that is the answer, option D. Little complicated question here. So we have to use the circle concept as well as the square concept, the diagonal of the square and circle, combining both, and then simplification. The major part that took a little time for us was the simplification part. So we simplify by rationalizing the fraction, multiply root 2 minus 1, dividing by root 2 minus 1, and then opening the bracket, and then getting the answer finally as 6 minus 4 root 2. The radius of the smaller circle is 6 minus 4 root 2. That's the answer to question number 9. So we have taken 9 questions from geometry, 2 of the questions at the end, 8 and 9 little complex one, and then 1 to 7 the basic questions, to give you an understanding of the various difficulty levels that you can see in different examinations, and so that accordingly you can prepare for your respective examination. Alright students, so this was the second class for today on geometry question discussion, and now we'll be doing the third class from 12 o'clock, that will be on general awareness, giving you a mixed bag of questions from 4 different topics, and just to discuss some important questions from general awareness for different examinations that are there, in which static GK or general knowledge is a part of the examination, particularly for exams like CLAT, FCAT, SSC, even some of the banking and MBA exams also have questions from static GK. So I'll see you next at 12 o'clock with the third session for the day, that is on general awareness. Thank you for joining with me for this class, and I hope to see you again in the class at 12 o'clock. Thank you so much.